All right, this is going to be the fourth and final video for Notes 49. We're due problem number 4. And all of these videos have been on graphing quadratic inequality. Why am I calling them inequalities? They're quadratic equations. Apparently need a break after doing 4 of these videos. So let's start with the axis of symmetry. Axis of symmetry is going to be x is equal to the opposite of b over 2a. Our b value in this problem is positive 2. So the opposite would be negative 2. 2 times your a value is the coefficient x squared. It's going to be negative 1. So negative 2 over negative 2, that's going to give me an axis of symmetry of just 1. All right, so I've got my axis of symmetry, which also means I have half a vertex. I know the x value of the vertex. I need to figure out the y value of the vertex. So little substitution here. So y is equal to replacing each of those x's with 1s. So 2 times 1 and then plus 3. So 1 squared is 1, and then I'm going to make it negative. So negative 1. 2 times 1 is 2 plus 3. So 2 plus 3 is 5. 5 minus 1. My vertex is 1, 4. All right, so now I'm going to find my zeros, my x-intercepts. Whoops, wrong thing. That's what I wanted. So I'm going to make y equal to 0 for my x-intercepts. So 0 is equal to negative x squared plus 2x plus 3. I am not a huge fan of dealing with that negative in front of the x squared. So what I'm going to do is move these terms to the left side. By moving them, that will get rid of that negative sign. Now, it's also going to change all the signs. So adding x squared, subtracting 2x, and then subtracting 3, make it equal to 0. I am much more comfortable factoring when my x squared or my leading term is positive. All right, so I'm going to split the x squared. Let's see, negative 3, and I need to add up to a negative 2. So minus 3 plus 1. That will get me x minus, right, an actual 3. There we go. X minus 3 equals 0, and x plus 1 equals 0. So adding 3 to both sides, I'm going to get x equals 3. Subtracting 1 from both sides, I get x equals negative 1. So my zeros are going to be the points 3, 0, and negative 1, 0. And right before I actually graph, I'm going to go ahead and find the y-intercept. To find the y-intercept, I'm going to set x equal to 0. So the original equation was y is equal to negative x squared. So I'm replacing that squared, x with 0. Plus 2x, again, replaced with 0, and then plus 3. So 0 squared 0, make it negative. You can't make 0 negative. 2 times 0 is 0. So 0 plus 3, I have a y-intercept of just 3. So now that I've got all the bits, parts, and pieces, at least the ones that I can graph, vertex, axis symmetry, zeros, and y-intercept, let's actually put it on a graph. So let's see, 1, positive 4, right? From the origin, go right 1, up 4. Let's see, axis symmetry, I can go ahead and graph that dotted line exactly through that vertex point. So there we go. Zeros, we've got, let's see, 3. So 3 on the x-axis and then negative 1 on the x-axis. And 3 is my y-intercept there. So I've got all the points in the right places. The axis symmetry is definitely showing me the mirror image here. So this point is 2 units to the left. This point is 2 units to the right. So that helps me know I'm in the right place. I've got pretty much the right stuff going on here. The curve is, of course, going to be a curve. So U-shape, curve, 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 in and out of all your points. Right, the closer those points are together, probably the easier it is to graph them as a smooth continuous curve there. Domain for a quadratic function like this is going to be negative infinity to infinity. That represents all the possible x values you can input into the problem. Graphically or visually, if you look at this graph, how far to the left does it go? It goes forever to the left. How far to the right does it go? It goes forever. Now you might be thinking, but it's going down. Yes, it's going down on both sides, but it's also getting wider apart as it keeps getting down and down and down. So that means we're going to continue moving to the left and to the right. Range-wise, what are the possible values I can get out of the function? Well, we've got a whole bunch of values down here. In fact, we've got an infinite number of them. So negative infinity is my low. But there is an upper boundary that we never cross, right? That vertex is the highest point this graph gets to, and that has a y value of 4 with a bracket, of course, because there is an actual point where y equals 4 that is part of your range. All right, that's going to be the end of the notes for all 49. But if you have any questions, concerns, please let me know, and I'll see you in the next one.